Dante Certification Level 2, 2nd Edition. Automatic IP addressing. When our devices join a network, it will need to get an IP configuration, including the IP address, subnet mask, gateway, and a list of DNS servers. The IP address needs to be different on each device, but the other settings will likely be the same on all devices. So, when we set up a DHCP server, we'll have two primary settings. There's the range of IP addresses to hand out. We might call that the DHCP pool. And we have to determine a lease time. That means once we hand out a configuration, how long is it good for? Now, on your home router, it probably defaults to a 24-hour DHCP lease time. But of course, if you go to a Starbucks, a McDonald's, or an airport, you might find the DHCP lease time drops to, say, 1 or 3 hours. Let's walk through the process and we'll see why. So here we have a device that wants to join the network. It needs to contact the DHCP server for an address, right? But it doesn't know where the DHCP server is. So how does it reach that? A device will send the DHCP request as a broadcast message. Now, the broadcast message is a special type of message that goes to every port on the network. Everyone else will ignore this, but the DHCP server will hear it and respond with an IP configuration. The server makes note of the MAC address of the requesting device, the IP address it handed out, and when the DHCP lease will expire. So here comes another device. When its network ports light up, it'll send a broadcast DHCP request that goes to everyone. Again, only the DHCP server responds with the configuration, noting the MAC address and expiration for that configuration. And on this goes as devices join the network. Another broadcast DHCP request, another configuration is given, and so on and so on. So let's get back to this question of why we have a DHCP lease time. Well, once a device gets the configuration from the DHCP server, it does not maintain a connection. So if a device was to leave the network, the DHCP server wouldn't know that. Without a lease time, once the IP address is given, it would be permanent, right? And so eventually you would run out of IP addresses. By having a DHCP lease time, as devices leave, their IP addresses can be recycled to be given out to other devices later on. Of course, if the device is still on the network as the lease nears expiration, it will contact the DHCP server asking to renew the lease. The DHCP server will simply update the record with a new expiration and communicate that back. It's worth noting that the DHCP server will try to keep devices at the same IP address. This way, if there's any streams or downloads in progress, there's no interruptions. If you want a way to visualize this, imagine a business, right? Like a coffee shop. Oftentimes, they won't own the building they're in. They'll have a lease with the landlord. Well, if you were to go to the business on the last day of their lease, you get your coffee. The next day you come in, if they've renewed their lease, you don't know that that happened, right? That all happens seamlessly in the background. The only time you know is if you go the next day and there's a note in the door that says, "Thank you for your patronage. Please visit one of our other locations." Right? Then you've missed your coffee for the morning. That's what happens on the network if you change your IP addresses. To avoid that, the DHCP server will try to keep everybody at the same address. So, if everything goes as planned, we contact the DHCP server and we get a configuration. We've got that. But what happens if you're set to automatic addressing and there is no DHCP server? Well, the automatic option will try DHCP first. If that fails, then it flips over to a protocol called link local. Link local assumes we're joining a much simpler network. It attempts to establish an IP address in the 169.254 range with the associated subnet mask. So link local really has two goals. First, we want to be able to join without creating an IP conflict. But second, if we can have our devices join in a common subnet, once they're in, they'd be able to communicate with each other. And that's handy. Now, link local will not try to establish a gateway or a DNS. It probably doesn't apply in this setting anyway. Link local will only work on your local network. It will not go through the router or out to the internet. So, If DHCP looked like this, with the router, firewall, and the whole bit there, then link local looks like this. It looks a lot more stark, doesn't it? Using link local, a device joining the network will pick an address at random in the 169.254.anything range. It will then send an ARP who has request. This is a broadcast message going to all ports on the network. Basically, it's asking, is anybody using this address? In this case, wouldn't you know it, the first device there is using that IP address. So it will offer an ARP response saying, yes, I'm using this address. Please choose another. The device picks another address at random and sends an ARP who has request again. So this gets to an interesting point. If I send an ARP request and somebody is using that IP address, I'll get a response. But if I send an ARP request and nobody's using that address, I don't get a response. So we set a timeout value, at which point we say, you know what? Possession is 9/10 of the law. I'm taking this address. And that is how link local works. Now, it's worth noting that once Dante devices get a link local configuration, they continue looking for the DHCP server. And this is helpful because sometimes people will just put a bunch of Dante gear in a rack along with the networking gear, all on the same power switch, right? It's not uncommon for your Dante devices to boot up faster than your network switch. So what would happen? You turn it on, the Dante devices boot up, and they might discover each other. Start with link local. Once the networking equipment finishes booting up, the DHCP server comes online, and the Dante devices will flip over to it without an issue. So in summary, when we set a device to automatic IP configuration, it will try DHCP first. DHCP servers will issue from a pool of addresses, and configurations will have a lease time or an expiration date to make sure that addresses can be recycled when devices leave. If the device is still on the network when the lease nears expiration, it will simply renew so it stays at the same IP address. If there is no DHCP server found, then devices will use link local as the backup plan. They'll choose an address at random in the 169.254 range and send an ARP request to make sure it's available. If it turns out another device is using that address, then it picks another IP address at random until it finds an available address. In the event that a Dante device gets an address by link local, it will continue to watch for a DHCP server.